Greetings. Welcome to the first in a series of lessons on systems of linear equations and how to solve them. Pretty much everything to do with systems of linear equations. So let's start out with probably the most important thing. Well, what is a system? So what is a system of linear equations? Now, we remember from past lessons that linear means we're dealing with a line, straight lines, and nothing else. Now, system is two or more lines. Okay, we're going to focus in this series on two. Okay, where do two lines intersect? That's really going to be our focus here. Okay, where do two lines intersect? So we want to know, where do two lines intersect? Okay, so a system is two lines or more, but we're going to focus on two. So the next question I want to answer is, what is the solution to a system? Okay, and we're going to just be able to sort of not really abbreviate, but just shorten it to system. In this case, stands for system of linear equations. So if I say a system, I'm specifically saying a system of linear equations. So what is a solution? A solution is the point where the two lines meet. That's what we're going to be trying to figure out. Where do two lines on a graph meet? Okay, now we're going to be doing this not always graphically. We won't always be doing it with a graph. We are going to be doing it, we're always thinking about the graph, and that it will be the first one we look at, but later on we're going to be using some other methods that I think are fascinating, because they seem to be like, this is all about a graph, and then we won't even need to use a graph at all, which I think is an amazing feature. But we're not there yet. Okay? So a solution is the point where the two lines meet. Okay? So we're going to look at a couple of things. It's going to be kind of a short one here today. But this is what we're always on the lookout for. Now, one of the kinds of questions, there are basically sort of two situations where we're going to encounter this, that we're going to talk about. Now, there's lots of times when two lines might meet and we would care about it. Like I said, it could be that we don't want them to meet, like an air traffic controller. We don't want to know where these two planes are going to crash if we let them keep going, or maybe we do. Maybe we want to, intercept a pass, or the ball is going this way and we're running this way and we want to know where they meet, those sort of things, et cetera, et cetera. But oftentimes what you'll get is you'll just get a simple question, is, and then they'll give us a point. Is the point, we're going to make this nice and easy, is the point 1 to a, it's not even a, it should be the, because there's only one, solution to the following system. So they're going to give us a point. They're saying, is this where they meet? Okay? And then they'll give us two equations. And they can give us the equations in any form that they want. Point slope, slope intercept, standard form, who knows? Okay? So maybe they give us one like y equals, let's just make my life easy, x plus 1. And then they'll give us, that's one equation, and then maybe they give us a second equation. How about 2x plus 3y equals 8? And they want to know, is this the solution to this system? In other words, if I were to go through the process of graphing these two lines on the same graph, would they intersect at this point? Now you have a few ways you can do this. We could actually go through the process of graphing them and then see visually where do they intersect. Now that is something we're going to kind of be doing in the next lesson after this one, or yeah, the next one after this one. So I'm going to save that. What I really want to do now is just check it numerically. Okay, so checking numerically simply means if I put, so this is always an X and this is always a Y. If I put in a 2 for this Y and a 1 for this X, do I get a true statement? Well, certainly 2 equals 2. That worked out. If I do it, so far all that has told me is that this point is on this line. Now for it to be where the two lines intersect, it needs to also be on this line. So if I replace the X with a 1 and the Y with a 2, do I get a true statement here? 2 times 1 is 2. 3 times 2 is 6. Does 2 plus 6 equal 8? Yes, it does. So now, because this is the point, this point is on this line and this line, there's only one point that can be on both lines. Therefore, it is the solution. So this would just be a yes. Yes, that 1, 2 is a, or it is the, I should keep saying the solution to the system. And again, now we're going to really just abbreviate. We're not even going to say, of linear equations. We're just going to say system. Okay? All right. Now there's another way for us to identify a solution. Okay? So oftentimes they're just going to give us a point and say, is this the solution? And all they're basically saying is, plug it in and see if it works for both. And if it works for one but not the other, then what that would relate to would be something like this. If I were to draw a graph, what we just saw, the point was 1, 2. That is the point that is on the line that looks like this one, and a line that looks like this one, and this is where they intersect. If it works for one but not the other, it could be this point over here, because it's on this line but not on this line. So there's going to be lots of answers that work for one but not for both. Only one answer can work for both. Okay, there are some special cases, we'll deal with them eventually, but for right now, there's really only one. There's only one place where they can meet. I don't know what it is, but there's only one. Now, the other way you might get given a problem is just like I drew, but I'm going to draw it again one more time. This time I'm going to be a little more careful. So I have myself a little couple of equate. So I got myself a little graph here, and let's give myself, that's a, so that would be that equation. So that's this one. And then this equation. And this one might be, oh, let's make it, I know what the equation is, so it's y equals negative 2x minus 1. Now this one I made as easy as I can on myself because I can see just based on the slope-intercept form of the line that we're using here that the point where these two intersect is the point 0, negative 1. And I know that because they both have the same y-intercept. Now, that may happen. It's not very common and certainly not very interesting because there's not much for you to do, but we're going to do it all anyway. Okay, so first of all, I drew the picture. Then I have to look at the graph and see where did the two lines intersect? So I visually have to be able to read the graph and see, hey, these two lines intersected at this point right here. And this point is 0, -1. So instead of me saying, is that the solution? I visually just identify it. Now I just want to prove it. Okay, I want to verify that that is the real solution. So it's not enough for me to just say, hey, is that a solution? I'm declaring that it is the solution, and now I'm proving that it works by plugging, again, this in for x, this in for y, and I'm putting them into each equation to make sure it works. So here we go, -1 equals 0 minus 1. Well, yeah, that actually, again, real nice and easy. Here we go, -1 equals -2 times 0 minus 1. Well, you know, -2 times 0 is 0. 0 minus 1 we know is -1. So I prove it by plugging it into each of the equations to then to justify that it is exactly the point it says it is, the point that is on the line. And if the point is on both lines, then it is the place where those two lines meet. So even if you visually think, oh, it's so obvious where it meets, you're going to have to prove it. And the way you prove it is you mathematically plug the numbers in for x and y and prove that it gets you a true statement for both equations. Because again, there's only going to be one that is true for both equations. And when you get one that's true for both equations, then you have the intersection, you have the solution to the system of linear equations. Okay, so at this point we have just a little bit. Okay, we know what a system is. A system is two or more equations. We're going to focus on two. We know that a solution is the point where the two lines intersect, and we can prove it by plugging that point into both equations and making sure that we get a true statement. If it comes out false, for whatever reason, if I'd put in 0, -5, it wouldn't work. And that would tell me, nope, this point is not on that line. And if it's not on either line, you don't have to prove that it's not on both. As soon as it fails for one, it can't be the place where they intersect, because it can't be, it's got to be both. It's all or nothing. So if it's ever no, you can stop and say, well, it didn't work for that one, so I don't even care if it works for this one. It's a no. Okay? So that is what a system of linear equations is, and specifically what we're going to be looking for the next 8 lessons, I think 9 lessons, is the solution to the system. Where do the points meet on a graph? So either if I were to graph them, where would they meet? Or if I already have them graphed, where did they meet, and can I prove that's exactly that the drawing is correct? Okay, I don't have to take it for granted. I can prove it. Okay, so that's it for today. I look forward to seeing you in class or in office hours.